Hi, my name is Hung-Chieh. Today I'm going to present our work on universal delimitation, and this is a joint work with Poilu and Shantin Lin. We studied the problem of how to adapt to distribution shift. In our setting, there are two types of shift. The first is domain shift, where, for example, source data may come from a real-world distribution, where target data may come from a pending distribution. The second is category shift, where some classes are shared between domains, while others are private to each domain. The goal is to adapt and achieve good performance on the target data, which is the central objective of universal delimitation. Although there are extensive work on universal delimitation, we first aim to rethink what constitutes a comprehensive universal delimitation setting. In our study, we examined the ratios among three distinct class sets: the source private class set, the shared class set, and the target private class set. We found that existing work and benchmarks fail to cover the full spectrum of universal delimitation scenarios. They primarily focus on cases with high target ratio and high share ratio, while largely ignoring cases with a high source private ratio. We refer to the latter as extreme universal delimitation. Extreme universal delimitation is common in today's applications, where we may train our models on large-scale internet data with a large number of classes, and are then adapted to a specific target dataset containing far fewer classes. A common approach in universal delimitation follows the procedure. First, a supervised loss is applied to the label source data. Then, a domain matching loss is used to align data belonging to shared classes. Since the true labels of the target data are unknown, they are often estimated using uncertainty measurements. Surprisingly, we found that in extreme universal delimitation, the common paradigm fails to outperform the simplest baseline that trains only on source data. This suggests that domain matching loss does not provide benefits during training. To study this problem, we first revisit the training process. We begin by applying a supervised loss on the source data. The model is then used to extract representations from both source and target data. These representations are used to compute uncertainty scores which guide the domain matching process. We hypothesize that representations are crucial for effective domain matching, as they directly influence the accuracy of uncertainty estimation, which in turn affect the domain matching process. To observe how representations behave under extreme universal delimitation, we begin with a toy example. Circle represents source data, and crosses represent target data. The figure on the right shows that target representation after training with cross-entropy loss on source data, where they collapse along a single line. In a non-extreme universal delimitation setting, after training with cross-entropy loss on source data, we observe that the target representations better preserve their structure and do not collapse. We also verify this phenomena on high-dimensional data. We use the singular varied spectrum of target representation to measure representation quality. As the source private ratio increases, the problem of dimensional collapse becomes more severe. The next question is how to address the dimensional collapse of target representation without using any labels. We draw inspirations from the self-supervised learning literature, where uniformity is used to mitigate dimensional collapse caused by pairwise alignment losses. We show that uniformity has a similar effect in universal delimitation, where applying to unlabeled target data helps preserve the data structure and prevents collapse. Our experiments show that incorporating self-supervised learning consistently improves performance, with significant gains in extreme cases. This result echoes two key points. Dimensional collapse is severe in extreme universal delimitation, and SSL effectively mitigates dimensional collapse. So the main takeaways are: first, representation quality really matters for effective domain matching. Second, representation is affected by category shifts. And finally, self-supervised learning methods that help address dimensional collapse can serve as a good starting point for universal delimitation.